Today we are going to test the foam stabilized base we set in place yesterday. One thing we are not factoring in is the fact that we have not backfilled the last 24 inches because we want to see how the foam responds to 5,000, 10,000, and finally 15,000 pounds of pressure. When completely backfilled to grade, the base would be even stronger and more secure in the earth. Today, we are utilizing a Dillon ED Extreme dynamometer rated to 55,000 pounds. Here, we are connecting and positioning the Dillon dynamometer. Here is our first pull to 5,000 pounds.
We've got 6,000 pounds of force on it right now. Looks like we've got about a 1/4 inch gap pulled back on the foam. We're going to take it up to 10,000.
Next, we are taking the pressure up to 10,000 pounds.
That's 11,000 pounds of pressure. It looks like we got about a 3/4 inch gap on the foam. We're going to try taking it to 15.
Finally, we put 15,000 pounds of side pressure on the base.
That's 15,000 pounds of pressure. We finally moved the pole stabilizer foam about 1.25 inches. We're going to release it back now and see if it repositions. Looks like we retracted back about 1/2 inch. We've still got about 3/4 inch of gap, but that was after 15,000 pounds of side pressure.
As you've seen when testing at 15,000 pounds, we moved the base approximately 1¼ inches at the 2-foot depth. Had we backfilled this base to the grade we estimated, we would have limited the movement to 1/2 inch or less. But our goal was also to demonstrate that the foam did not crack or break at the 24-inch depth level. When released, the concrete base retreated back to the 3/4 inch gap at 24-inch depth. Next, we decided to place a force on the actual steel pole at 5 foot above the concrete base. Here, you can see from the actual footage the pole bends over at 5,000 pounds of pressure. Our conclusion is that on a typical pole installation, the pole or post of a light or a sign will bend or break well before the concrete base will be dislodged after being set with pole stabilizing foam. We decided to pull the base to inspect the foam and were amazed at how it is adhered to the concrete base. As you can see, the density of the product is much greater than typical native soils. Please note, we have prepared this test and video as a demonstration of an easier installation method for our concrete bases. We have not been paid, nor have we been solicited by any stabilizing foam company.